everyone. This video will show how to sketch the graph of hyperbola with center at HK. So before we go over this example we have right here, let's have a review on the basics of hyperbola with center at HK. There are two cases of hyperbola with center at HK. Now let's go over the first case. The first case is the horizontal hyperbola, and this is its formula. Now please notice that we can form a horizontal hyperbola if the x part of the equation is positive, the one that I put inside the square. Let us locate the center of this hyperbola. Point C is the center of the hyperbola, and the coordinate for the center of horizontal hyperbola is HK. Now let's locate the vertex of the hyperbola. These are the two vertices of the hyperbola, and the coordinate for these two vertices would be h plus a comma k. Now we remember that the distance from the center to the vertex is a. We also have co-vertices, and we're going to label the co-vertices in this picture. The distance from the co-vertices to the center, or the distance from one co-vertex to the center, is b. The coordinate of the co-vertices is h, k plus b. The next part of this horizontal hyperbola are the asymptotes. In order that we can easily draw the asymptote, we are going to draw a rectangle. This rectangle should cover these 4 points, the two vertices and the two co-vertices. The asymptotes in a horizontal hyperbola passes through the corners of the rectangle, passing through the center. The equation of these two asymptotes would be y equals plus minus b over a quantity x minus h plus k. We also have the focus. The coordinates of these two foci would be h plus c comma k. Now let's move on to the second case. This graph illustrates the second case of hyperbola, which is the vertical hyperbola, and this is its formula. Now please remember that in this case, the y part of the equation is the positive part. So that's very important, because this will tell us that the hyperbola is a vertical hyperbola. The one that I squared is the positive part of the hyperbola, which is the y part. Now let's locate the center of this hyperbola. This is the center C of the hyperbola. Now let's draw the two vertices of this hyperbola. These are the two vertices of this hyperbola. Now we remember that the distance from the center to the vertex is a. This tells us that the coordinate for the two vertices of this vertical hyperbola is h, k plus a. We also have two co-vertices for vertical hyperbola. These are the two co-vertices of a vertical hyperbola, and the distance from the center to the co-vertex is b. And the coordinate of the two co-vertices would be h plus minus b comma k. This vertical hyperbola has two asymptotes. In order that we can easily sketch the asymptotes, we are going to draw a rectangle that passes through the two vertices and the two co-vertices. The two asymptotes for vertical hyperbola passes through the corners of this rectangle, passing through the center. The equation of these two asymptotes for vertical hyperbola is y equals plus minus a over b quantity x minus h plus k. Now we also have two foci for this vertical hyperbola. The 2 points labeled F are the two foci of the hyperbola, and the coordinate of the two foci would be h, k plus c. These are the two cases for hyperbola. The first case is the horizontal hyperbola, while the second case is the vertical hyperbola. Okay, going back to the example that we have right here, if you notice, the positive quantity that we have here is this quantity. That's quantity x plus 1 squared over 9. Again, that's the positive quantity. This tells us that this is an example of a horizontal hyperbola. So I'm just going to go ahead and write that up here. Now we remember that whichever has a positive quantity, we take its denominator as the a squared. And so this tells us that 9 is our a squared and 4 is our b squared. So we're going to go ahead and solve for a and b. Okay, now we go ahead and determine the center of this hyperbola. So the center is hk, so that's going to be negative 1. And so I'm just going to write negative 1 right there. And then that's a positive 2. So that's the center of this hyperbola. So I'm just going to go ahead and sketch that down here. So that's negative 1 and positive 2. So it's going to go up here. So this is our center. So I'm going to go ahead and label this as letter C. Now we remember that this A value tells us the location of the vertices. So in this case right here, since this is an example of a horizontal hyperbola, we can go ahead and say that we go 3 places to the left and 3 places to the right to determine the vertices of this hyperbola. So these are the coordinates of the two vertices. Again, I counted to get the first vertex. I counted 3 spaces to the left and 3 spaces to the right from the center. Now, to determine the co-vertices, the b value is going to give us that. So I go up 2 and down 2 and determine the coordinates of the co-vertices. Okay, the next step that we are going to do is to create the rectangle using these coordinates or points that we have here. So this is how the rectangle is gonna look like. Now this rectangle will give us a guide on how to sketch the graph of the hyperbola. This will make our life way easy in graphing the hyperbola. So we created the rectangle. Now the next step that we are going to do is to sketch the asymptote. The asymptotes are the 2 lines that would pass through the corners of the rectangle, passing through the center. So I'm gonna go ahead and draw the first asymptote right here. Okay, now we remember that the equation for an asymptote for hyperbola that has a center of hk is given in an equation y equals slope x minus h plus k. So in this case right here, we take this first first diagonal or this first asymptote. So that is equal to, the equation for that would be y equals the slope. The slope is from the center to the other end of the rectangle. So that would be 1, 2, 1, 2, 3. So that is 2 over 3. That's the slope. Again, and that is equal to x minus our h is negative 1. So x minus negative 1. And then we have a plus k, which is 2. So I'm going to write 2. So simplifying this, this will come out y equals 2 over 3 x plus 1 and then plus 2. So this is the equation of this asymptote right here. So I'm just going to go ahead and label that. And the equation of the other asymptote would be its slope is going to be the opposite. So that would be y equals, we start from the center, I go up to 1, 2, then I go to the left 1, 2, 3. So that is negative 2 over 3. That would come out x plus 1 and then plus 2. So these are the two equations of this asymptotes that we have right there. Now from here, we can go ahead and sketch the hyperbola. Since we say that this is an example of a horizontal hyperbola, I can go ahead and sketch the first branch of the hyperbola right here. So when we sketch it, it approaches towards the asymptote but will not touch it. So this is pretty much like two disconnected parabola graph together. So I'm going to draw the other side of the hyperbola right here. So this is the graph of this equation that we have up there. Now, our next step is to determine the two foci. To determine the location of the two foci, we need to determine the value for c. The formula to determine the c is c squared equals a squared plus b squared. So we already have an a squared right there, which is equal to 9, and b squared, which is equal to 4. So I'm going to go ahead and solve for c. This tells us that our focus, or the two foci, are located square root of positive negative square root of 13, which is approximately 3.61. So this tells us that the two foci are located 3.61 units from the center. So I'm going to go ahead and count 1, 2, 3.61. That should be somewhere here. This is the fourth one. So that's located somewhere around here. So this is our first focus. And the other focus would also be 3.61 units from the center. That's 1, 2, 3.61. That should be somewhere around here. So this is the other focus. Now we remember that we can actually determine the coordinates of the two foci following this. So that is h plus c comma k and h minus c comma k. So from here we can go ahead and say that the first foci would be, that's going to be our h is -1, so I write -1, and then plus square root of the p, or the c is square root of 13, so plus square root of 13, and then comma k, our k is 2, so I put 2 right here. And if we change this to decimal, this is actually equivalent to positive 2.61. That's the x. So if we do the math on this, that's 2.61, and then 2. That's actually this foci that we have right here. So that is 2.61, and then the other one would be that's gonna be h minus c. So that is -1 minus square root of 13 comma 2, and if we change that to decimal, that would be -4.61 and then 2. So -4.61, so that's right here. X is -4.61, and then positive 2 on the y. So that is where the two foci are located. Now we determine the eccentricity. So the eccentricity formula is, that's gonna be E is equal to C over A. Our C is square root of 13 and our A is 3. So this is the eccentricity of this hyperbola that we have up here. Now let's move on to the next example. Now let's go over this second example here. Please notice that the positive quantity is the y. This tells us that this is an example of a vertical hyperbola. And then I'm going to go ahead and write it down here. Now we remember that the value of a squared should be the value that's in the denominator of whichever has a positive quantity. So this will be our a squared and this will be our b squared. And I'm going to go ahead and determine the value for a and b. Okay, now the next thing that we determine is the center of this hyperbola. Now we remember that the center is hk, so this is positive 3 and then -4. So I'm going to go ahead and sketch that center up here. That's going to be positive 3, that's 1, 2, 3, and then -4. So it goes down all the way here. So this is our center. Now we remember that The vertex or the two vertices are located a distance from the center. So in this case right here, since this is an example of a vertical hyperbola, so the first vertex will be located above the center and the other vertex will be located below the center. So I'm just going to go ahead and locate that. So that's going to be 3 units up and 3 units down. So these are the coordinates of the two vertices. To determine the co-vertex, again, since this is a vertical hyperbola, we will take the value of B, and that's gonna be, since this is vertical hyperbola, we're gonna take 4 units to the left and 4 units to the right. So I'm going to go ahead and draw the rectangle that will guide us how to draw the hyperbola and the two asymptotes. And we remember that the equation for the asymptote is y equals slope, and then that's going to be x minus h plus k. So I'm going to go ahead and write the equation up here. So this is the equation for this asymptote right here. Now let's find the equation of the other asymptote. So it's going to be the other way around. It's negative. So I'm going to go ahead and write that up here. So we can go ahead and sketch the hyperbola. Now, the next thing that we determine is the location of the two foci. To determine the location of the foci, we need to determine the C, and this is how we solve for the C. Okay, the C value is plus minus 5, so that we can go ahead and count 5 units from the center up and 5 units from the center down to locate the two foci. The formula for the coordinates of the two foci for a vertical hyperbola is h comma k plus c. So in this case right here, we're gonna start with the first one. So that's gonna be h. Our h here is 3. So I'm gonna write 3, and then it says k plus c. So our k is negative 4. So that's gonna be negative 4. Plus 5, and this tells us that this is actually 3 and positive 1. So this is actually this focus that we have right here. So 1, 2, 3, and 1. And then the other foci is, or the other focus is located 3, and then that's gonna be k, which is negative 4, minus c, which is 5. So in this case right here, we can simplify this as 3 and negative 9. So I'm just showing you for this example, the C value is a whole number. Sometimes the C doesn't have to be a whole number. That's why I'm showing you how to easily determine the coordinates of the foci using the equation h comma k plus minus c. So this is the graph of this equation that we have up there. Now, we need to determine the eccentricity of this hyperbola. So this is the eccentricity here. E is equal to C over A. Again, our C is 5, and then the A is 3. So this is the eccentricity of this hyperbola. That's it. If you found this video helpful, consider subscribing and hitting the like button for more math videos. See ya!